Okay, in this lecture we're going to talk about the general form for a linear function, and we're going to talk about the slope. Now, the general form for a linear function is this form here, ax plus by equals c, where a, b and c are real numbers. And if we want to go ahead and try and graph this, all right, sometimes this is called the general form or the standard form. And to graph it, for example, this one here, of course, we look for the intercepts. Okay, so we first of all look for the y-axis intercept, and this occurs when x equals 0. So what we do is we say, well, 3 times 0 plus 4y equals 0. So what I have is 0 plus 4y equals 0, which of course implies that, of course, y is equal to 0. So it actually goes through the origin right here, which means that we can't find a second point because the x-axis intercept is also the origin. So we need another point. And you can choose any point you like, but you try and think, well, what's going to be an easier one to get? So what if I was to put in x is equal to 4? Okay, then I'd have 3 by 4 plus 4y equals 0, so I'd have 12 plus 4y equals 0. And the reason I put 4 in there, of course, is because I'm going to be able to divide through. So this implies that 4y equals negative 12, or y equals negative 3. So our point will be 4, negative 3. So 4 is here and negative 3 is here. And it doesn't hurt to check another point, just to be sure that you're right. So there's our graph of this particular linear function. Next thing I want to talk about is the slope. Sometimes it's called the gradient. It has to do with the steepness, right, of the function, in this case linear function. Right, so if you look at this here and we look at this this particular line like this, all right, that's steeper than, say, a line that's like this. And of course these two are not as steep as a line that's like this. All right, so this is the steepest here. So this would have the largest slope. Now, this is the shallowest here, or the least steepest. So it has this smallest slope. All right, so what do we mean by the slope? Well, the thing to look at is this. Well, what if I did a triangle like this? We kept this x the same. Let me do it over here, perhaps. If I go like this, that's a steeper slope than if I did it like this. Same x here, change in x. We call that the change in x and denote it delta x. And then we look at this ratio, this height here as compared to this one. This is what we call the change in y. So the slope is actually given by, well, what's the ratio of the change in the y to the change in the x? Okay. Notice that this one has when I keep delta x the same, this one is larger, so therefore it will have a steeper slope. So our slope then can really be looked at as the rise divided by the run. How far you run in this direction, this is the run, and then of course in this direction it's the rise. How far it rises compared to how far it runs. And it's often called the change in y over the change in x. Now what do we mean by that change? Well, if I had this one as x1 and this one as x2, then the change in x would be in fact x2 minus x1. And the change in y if this is y1 and this is y2, would be y2 minus y1. So in other words, the formula for the slope then for a line between 2 points would be y2 minus y1 over x2 minus x1. Right, so this is our slope formula, and the other thing to keep in mind is that going up like this would be positive. What happens if I've got my line coming down like this? So we have a steepness, but of course it's decreasing, and so it would seem that one of these would be negative. Remember when we talked about increasing and decreasing functions? If I keep these the same, all right, then one of these, of course, this first one will be larger than the second one here, so I'll get a negative. And so this would be a negative slope when it falls to the right. And it's a positive slope when it rises to the right. Okay? All right, so let's look at an example. So it doesn't matter which one of these you label as x1, y1, but be consistent when you put it into the formula. So x2, y2. So if I look at the slope between these two, all right, y2 minus y1 over x2 minus x1, I end up with, let's have a look here, it's negative 6, subtract 4, y is rise on the top, don't mix that up, and x2, which is going to be 2, subtract x1, which is negative 2. So I use a parenthesis there. So I end up with a negative 10 here, and I have a 2 plus 2 here. So I end up with negative 10 over 4, which of course is negative 5 over 2. Now what that is saying is that whenever I go 2 across, suppose I go here, and I go 2 across, there's 2 across, right, this is falling 5 units, 1, 2, 3, 4, 5. And so a slope of negative 5 and 2 is represented by that kind of slope. All right, so remember this is what this is designating. This is the rise and this is the run. Okay, so 2 units to the right horizontally means a negative 5 is actually rising negative 5, which means it's falling 5 units, all right, in the vertical direction. But if we look at this one, all right, so let's again, we can use this as x1, y1, x2, y2. So the slope again is y2 minus y1 over x2 minus x1. So in this case, I'm going to have negative 7, subtract 7, over negative 4, subtract negative 4. So I end up with negative 14 over negative 4 plus 4. So I end up with negative 14 over 0. Well, how do we divide by 0? Well, we don't. This is undefined. All right, now why is that undefined? Well, if you look at the points, we have, let me do this one up here. We have a negative 4, we have a negative 4, 7, which was right here. And we have a negative 4, negative 7, which is right here. And if I join those up, what do you notice? We have a vertical line. And so an undefined slope means a vertical line. Okay, and this of course is because the x values are the same. Okay, it's actually not moving anywhere in the horizontal direction. Let's look at this one. All right, and this one, again, it's y2 minus y1 over x2 minus x1. All right, so let's call this one x1, y1, and x2, y2. All right, so we end up with 6 subtract 6 over 5 subtract negative 5. So I end up with 0 on top, and I end up with 5 plus 5, which of course is 10. So I end up with 0 over 10, which of course is 0. So what's a zero slope mean? Well, it means it's not rising or falling, it's constant. All right, and so if I look at that and you look at the points here, it's going through -5, 6, and 5, 6. And notice when I join those up, I have a horizontal line. And so a slope of 0 means a horizontal line. So now we can find the slope of a non-vertical line, and we can determine whether a line is in fact vertical, because it will have an undefined slope, and we can also determine if a line is horizontal because it will have a 0 slope. And that's our concept of slope, and the steepness, of course, has to do with this particular ratio. So very important formula to remember.